So let's focus on the first scenario. Our domain expert says, after 6 months of service, discount becomes effective. A discount is a very important and crucial benefit for employees that will just be able to have some additional lower prices at the shop and so on. So here you can think that, well, okay, we have some time involved, 6 months, that's cool, and then discount becomes effective. And dealing with domain-driven design, we can talk about domain events which are facts that already happened in the past. So how about something which needs to be triggered on a precise point in time? It's a niche, as was already mentioned. I did a research, and Mr. Weber says that schedulers and timers are also very interesting types of events, but they are oftentimes an implementation level consideration. Not too much, just the implementation detail. Another very important persona in the domain-driven design industry, Mr. Worm, says that expiring timeframe will generally have a descriptive name that will become part of our ubiquitous language. That's better. We are just trying to tie those timeframes into our ubiquitous language with our bounded context probably. And he adds, therefore you have a name for that particular time-based domain event. This is from the idea comes from. Okay, so just in reference to our case, we can think that discount became effective is an event triggered by time. But what is this precise time frame? How we can call it? We asked these questions to our domain expert. He was already annoyed that we are trying to throw different concepts and questions at him, and he mentioned that when eligibility date is reached, so this is our expiring time frame, then discount becomes effective. That's cool. We have some understanding. There's some policy triggered by time, which is, has its specific name, the discount eligibility date, and it will happen after the 6 months of service. That's good. So having in mind this, we can recap what we already discovered. There is some experience time frame, which can be precise point in times, which influence our domain and are relevant from our ubiquitous language, and also are well named. On the other hand, we also know that this is niche. It's not quite common thing to speak precisely, explicitly about those time boundaries. And what is more, well, just implementation details, not implicitly something which can be covered on our domain. Let's move to another case given by our domain expert, just-in-time events. This time we will speak about modeling towards the time-based domain events, and it may be controversial. We'll introduce something which is called event scheduler. And you may ask, but events are about something which happened in the past. Why we would like to schedule an event? So we have levers in our company as well, and they influence how this benefit works for them. The other scenario is whenever employee leaves, an effective discount should be disassociated. On the diagram below, you may think that, well, that's a straightforward processing. We consume event on the left, employee left, perform some action, checking if discount is effective. It's our aggregate, which is just, let's say, the boundaries of our consistency of a state, and then the other event is published. Cool. Very easy. But I mentioned that we have dependency to our employee work cycle context, and on their side, they actually don't care about the exact date when employee leaves. They publish even that employee is marked as a leaver. And as you can imagine, in the real world, whenever you resign from the work, you will still be working for next 2 months, for example, right? So this leaving date can be in the future, or maybe can be in the past. There is one pattern which somehow references to such idea. It's called retroactive event, and I think that the author of this is Martin Fowler. I did check it. I tried to understand it. It's a cool idea. However, I found also this one. Retroactive event determination and the interpretation of microscopies, blah, blah, blah. And the same idea with retroactive events was there when we're talking about our system. So what we can do instead? Well, let's build some anti-corruption layer. A layer between our context, which will take care of transformation the event, which will for which the action will just happen in the future, and then only publish the relevant event, which is employee event, on the exact precise point in time. How we can achieve it? As you can see, well, the idea looks quite simple. Let's consume this event, the employee mark as lever, and schedule an event to happen in the future. Well, this is where the controversies arise. How to schedule event, and shouldn't we do anything, something different? Well, maybe. We decided to go that path. As I mentioned, we use Kafka in between those two contexts to communicate with each other. So it may, when it comes to the Kafka, we use Kafka streams. So have you ever used Kafka streams on production? Anybody? Cool. So very briefly, the Kafka stream is the additional library to the whole Kafka ecosystems, which is built on the pure consumers and producer concepts. It allows you to build some streaming pipelines over the Kafka topics, which looks like and offers some operation typical for pipeline processing like mapping, flat mapping, filtering, aggregation, and similar one. What is also important, they can have a state, for example, for counting or aggregation. So this piece of code shows how the streaming processing can look like using Kafka DSL library. It's quite cool, it's readable. We can consume events from one stream, group some events, and then aggregate them. Cool, that's very nice. However, we still didn't know how to postpone event publishing using Kafka DSL language. Well, what's Kafka ecosystem offers also? To build such solutions where from one topic on the left, we will just consume event, do some magic inside the ACL block, and then publish the expected event employee left on the effective events topic. There is something on which Kafka DSL is built, the processor API. It offers us just a common interface, the processor, and you may have already spotted that there is a very cool thing about this. Schedule. We can schedule something. That's cool. So let's dig in. The processor context is a basic building block when you implement a processor using processor API in Kafka, and it offers a schedule operation, which as a parameter takes duration, the punctuation time, and the callback, which will be triggered whenever we have another schedule. So speaking about timing Kafka, we can differentiate two types of it. There's a stream time. So it means that the time between the time which elapses is calculated between two events which arise on a Kafka. That's one thing. And the other one is a word clock time, just a standard word clock time that every 10 seconds, let's say, something will happen which we already stored in our callback. That's good. That might be building blocks, but there are some hidden dragons. And it is worth mentioning that the word clock time is the best effort, because when we process something within a Kafka stream application, it will be waiting until the whole pipeline is processed, and if defined time elapses, then our callback will happen. So the other question, where we put not effective events, because we can live in 2 months from now. I've mentioned that there are some state stores in Kafka processing, and they are kind of cool concept in Kafka. The Kafka DSL language uses it to store aggregations, the result of it, and we maybe possibly can use it as well. The other interesting and important fact is that they are also replicated. So you can choose if it's either the in-memory state or persistent state, which is backed by RocksDB. And this is another thing which is worth to remember, that there is a RocksDB, the additional technology involved in it. And it's replicated whenever we would like to rebuild the state because our application crashes, then it will be rebuilt from a topic, which is backed by, on which the state store is backed on. So, is it still feasible to do it with it? There is an idea to build a Kafka stream application and use state stores to store not effective events. Then we would like to schedule some punctuation to poll for only effective events and then forward to the output topic. Sounds like an idea. The topology looks like this in the first approach, that we have this input stream with employee events. We have a translator. I will show it in a couple of seconds what it does. Scheduler, which schedules event, and when the events are effective, it will be forwarded to another topic, and we use some state store. So right now I'm going to show you some code. It's in Kotlin. There are a couple of snippets, but I think they will be readable and understandable as well. So the first one, the translator. The implementation of process method. I know that when statement on just one singular condition is anti-pattern. However, this is just a snippet which will be extended later. I just showed it for the presentation purpose. So on this method, we only translate the input event, employee mark as lever, to employee left. And we would like to store this event with its effective date somewhere in our state store, but this is the only logic in this processor is to translate it and forward to another processing layer, which is scheduler itself. The only thing which it does, it just puts the events from this comments to our state store. And here we can just talk a little bit about the keys. Here you can see that the key consists of effective date, the employee ID, so some unique identifier of an event, which is also used for a partitioning purpose, and the type of an event. As a value, we use just a payload of it. So that's it. We start this as some strings, which are separated with colons, and store the event for a future. The events forwarder, the effective one, here is where we use schedule method with some punctuation type of walk clock time. So we are doing our best effort to, let's say, every 1 hour, do our logic, which is on this callback called forward and commit. So here, this is some compose method which forwards and commit. This is the forwarding part. It iterates over all effective events and just invoke the callback, which is about forwarding. So what it means to iterate of the effective events. As I mentioned, we have this key of effective date, employee ID, and event type mapped to an exact value of an event. So we do a range query. This is something which can be used because it's exposed as an API of Kafka streams. And here you can see a 0 and some tomorrow date. Why it works, you may ask? It works only because internally, and this is not a good thing that we are basing our logic on some internals, this persistent state stores use a lexicographical ordering. So whenever we compare strings, the 0, to any date, it always will be lesser. So this is why it works. And then we are forward our value. So this is some test scenarios. Kafka Streams also provides you with some test driver, which can be used in tests to check things like if events are forwarded, if events are published, and to spot on another very important thing. It's worth to abstract the time, to not base on some library time, just to have your own representation of time, which can, for example, be used in a test to move past to move time to the future. And this assertion ensures that whenever we already forwarded events, we won't forward them anymore. So, does it work? Almost, because as I mentioned, we are just having this query from a very early beginning to the to tomorrow. So whenever we forward, for example, and we have another schedule for 1 hour, we will have the same result from this query. So it will imply some duplicate events on our streaming. This is not what we would like to have. We would like to do our best to avoid them. So we introduce a cleaner. The another node which will just delete already effective events from our state store to do not process them anymore. So at the end, the topology with this approach looks like this. We show something, it is forwarded, and then with this effective event stopping, we will come back to our topology and clean the store. It will happen in one thread, so there is no risk that a couple of processors will work simultaneously on the same piece of data, so we are kind of safe to do it. And you also may ask if we are done. Unfortunately not, because there is another example. For example, let's say that I am a crucial person in a project and I was convinced to stay longer to deliver something, so I will postpone my leaving to even further future. So how it can be achieved with this infrastructure? Well, similar, start with some idea. We need to extend translator to translate events to another new events, like leaving postponed to employee left event. We need to also add new state stores, because right now we need to know what was the previous effective date, because we use it as a part of a key, and what will be the new one. So we need to store it somewhere. Also extend scheduler to put this event key on this new store, extend cleaner to clean new state store, and of course introduce another processor. So the topology looks like this. What has changed is this one piece, the scheduler, which comes from translator, and yet another store for different purposes. In the code, you can see that as well the processor implementation only operates on effective dates this time, not the effective events, because for any effective dates, if we find them in the new state stored, we would like to process with this logic. We would like to delete existing already scheduled effective event. We would like to put a new one, and then put dates to the another store. Okay, cool, we achieved it. What next? What if I was convinced with some doubled salary that I shouldn't have left the company? Well, I can just cancel my leaving papers, right? So this is another things which needs to be reflected, and another requirements which can be implemented with this yet another processor. Just call it counselor. This is also it is the last one, and the only thing which it does is to delete the from both stores events, the already effective shell effective events and the days to which it corresponds to. Here something went wrong, so I'm apologize for it, but you can find this presentation over the internet as well. So what we achieved, because maybe of some infrastructure constraint, we used Kafka to implement all of these time-related requirements. Also, it turned out that the processor API, maybe it's not so clean as DSL, but still is composable, and we can just extend our topology. What is important is testable. We can use all things which Kafka provides to the testings, and just on the level of just a one project test it with checking what will be the output of the topic. That's cool. Uh, as I mentioned, because of how the Kafka is built itself, we can achieve high scalability and fault tolerancy because of a stateful replication, topic replication, how we can spread amount of work between nodes. And yeah, this is what I already mentioned. What about some consideration? Well, we used low-level API. It's not so clean. It's still doable. Maybe it can be extracted to some additional library. I don't know. What is more interesting, we use two state stores, and we share them between processors. We have some guarantee that it will only used by one processor at a time, but still sharing state doesn't sound like a good idea. What is more important, we use some internals to query for effective events, which is just based on the RocksDB implementation underneath. And because there is no TTL in state stores, we need to clean them ourselves. So this is why the cleaner was introduced at the beginning. There is no way to expire any keys and values in the state stores in Kafka. And increased memory footprint and disk usage because of RocksDB. It may cause your application to some dead end. And the very good advice, abstract the time, because it then becomes handy to just move time back and forth. And well, this is something which is very, very needful. And the very last one, is it really suitable solution for scheduling? Shouldn't we use something else? I really would like to know your answer. And it leads me almost to the end of my presentation. There was a couple of links about the code base, the materials which I used to prepare this solution, and also some references to documentation and articles. Thank you very much, and I hope we have some time for questions.
Yep, we do have some time, a couple of minutes. So there are questions, and if you could change the screen to show the questions, might be easier. And that's the second tab, Q&A. All right, so the most important question is, what if deleting already scheduled events failed?
Okay. So as I mentioned, whenever what is guaranteed in a distributed system? At least one processing, out-of-order events, and at least one processing. Everybody knows it. So in these times, we will just have duplicates. That's all. And I think that the consumer of effective events should be prepared for with idempotency in mind, because even if we don't use this solution, we still may spot the same event more than once. So this is just a good advice for everyone when designing such systems. Have you tried using standard suppress DSL operator for postponing aggregate result? It's more elegant on processor API and finalized stable in latest Kafka version. I think that it has become stable very recently, so when I was preparing the solution, I didn't spot it. So this is why I also didn't decide to use the suppress, and I think the suppress is more about windowing. So the question is if this window time can be, like, for example, 2 months long. I'm not pretty sure how suppress works underneath, so this is good advice for me to check it. What about storing history of scheduled events versus deleting and then passing a date of lastly scheduled events, not 0? Well, yes, but you can imagine that I use 0 because one day, the last date, let's say, is Wednesday, and we process it. So we can store this last day of processing as a Wednesday, but on the other day, the other employee left. Well, not left, just decided to leave the company. So it may occur that he would like to leave much earlier than Wednesday. So this is why I always query for the early beginning, because these effective dates can be also in the past, not only in the future.
Okay. We still have 2 minutes, so feel free to post some questions. There, I think you scrolled. Yeah.
Okay. Have you used any Kafka streams, reactive streams connected like Alpaca? Do you think it may help to keep a code base consistent? No, I haven't used it. I've only heard about Alpaca. I think it's a better camel, Apache Camel, or something like this. So I'm not pretty sure how it can influence the code base to be more consistent. I need to check it. Thank you for advice. The other one, could a SQLS command be scheduled instead of entity? Yes, this is what we did for the first case where the discount became effective. Because this is something which is bounded to our context, and we, to be honest, we have this policy of discount LGBT date, and we know what should happen on that day. So this is an action. We should disassociate a discount, for example, or associate discount because this is the beginning of a journey. So in this case, yes, we can schedule a command, and it may be less confusing than scheduling an event. But this one was about the ACL to just ensure that we will get events as pure as we would like to be. Isn't the solution against dumb pipe smart endpoints pattern? Yes, it is, because we built this some logic in between two pipes, two topics. However, as on the other hand, we still have this, let's say, once again, pureness, that we only get events which we are interested in within our bundled context. Could the secret command be scheduled? Okay, this is the same. So
I think these are all the questions.
Yeah.
All right. So it seems that we could finish on time. Thank you for the presentation.
Thank you very much.